Welcome to Decarbonization Explained, a new sustainability series from Danfoss. This is episode 1, how we decarbonize industry. Every time we need goods, food, or comfort, we create emissions. Industry alone accounts for about 38% of global CO2 emissions from end-use sectors. By 2050, there will be 2 billion more people in need of resources and energy, and our economy will double. To build a better future, the world needs to decarbonize by decoupling growth from emissions. But to achieve a 2050 net zero scenario, we need to use 8% less energy than we do today. The question is that even possible? The answer is simply yes. We can decarbonize our industries with cost-efficient solutions available already today. At Danfoss, we have a method for decarbonization. First, we apply energy-efficient solutions to reduce energy consumption. Second, we reuse energy. And third, we source any remaining demand from clean energy sources such as renewable electricity and green hydrogen. Only in this sequence can we achieve rapid and cost-efficient decarbonization. We call it reduce, reuse, and resource. And we are using it to achieve our own carbon neutrality goals in 2030 for all of our 100-plus factories, 5 of which are already carbon neutral. And we're going even further than that.
At Danfoss, we aim to be our customers' preferred decarbonization partner. To be that, we really need to take a leading position ourselves. That's the reason why we have committed to achieve 100% reduction before 2030 on our own operation. The way we do that is to apply the decarbonization model on all our factories worldwide. The first step is always to look for energy reduction, so energy efficiency in all processes. Secondly, we look at how can we reuse the energy one time more, typically as waste heat. And the last element is really to look at how can we source renewable energy into our factory operations.
In this episode, we dive into how industries can decarbonize effectively with available solutions while also staying competitive. Let's first look at reduce. Reduce is essentially about reducing energy consumption, particularly in applications that run for a long time in factories. Fans, pumps, motors, assembly lines. They don't need to run all the time, but they often do. In fact, most factories keep their systems running 24 hours a day, 7 days a week. And many of these large machines are on constant standby when they could be shut off. In a recent pilot study at one of our sites, we found 80% of our machines could be switched off when not in use, saving 30% on energy without impacting productivity. Aside from simple but powerful shut-off initiatives, today many motors in industry productions are oversized for their purpose, meaning that they run inefficiently and are using far more energy than they need to. Actually, motors use more than half the world's electricity consumption and more than 2/3 of the industry electricity consumption. We can make them all run only when they need to, and a lot more efficiently by using the simple principle of variable speed.
So a drive is an intelligent piece of technology. It's not a standalone product. It's kind of a best friend of the motor that controls the speed and the torque and ensures energy efficiency in the motor applications.
A variable speed drive can be used for many kinds of motor applications like ventilation systems, water pressure control, or conveyor belts. It can be simply explained like this. In this example, a motor controls a fan. Without a drive, the motor will run at full speed by default, despite the power actually needed to operate the fan. There's no adjustment of the frequency and voltage, just full speed. After inserting a variable speed drive, the volt and frequency of the motor will be adjusted while keeping the airflow consistent. The energy reduction from installing a drive speaks for itself.
It is a recognized solution for energy efficiency to use a drive. For pumps and fan applications, for example, you can easily save 40% of the energy with the drive installed compared to the no-drive solution. In our own factories, we seize the opportunities where we can really improve the efficiency and install a drive. We had a recent retrofit in our US factory in Loves Park, where we had an old ventilation system. And we estimated that after the retrofit, we had 59% reduced carbon emissions compared to the previous system over the drive's lifetime.
The number of motors in the EU alone has major potential to decarbonize through energy reduction. In fact, this potential represents 53 terawatt-hours per year. This is equivalent to avoiding the annual footprint of up to 2 million European citizens. In our Wuqing factory in China, where we produce more than 500,000 compressors annually, we connected Danfoss drives to electric motors on 20 different workstations, saving a total of 30,000 kilowatt-hours. Even for heavy industries where hydraulic systems are widely used, for example, when working with injecting molding, variable speed drives can deliver energy savings up to 70% compared to a fixed-speed system. The decarbonizing potential with variable speed drives for any industry application using a motor is truly endless. It's just a matter of implementation.
The great fact also about the drive, it's you don't need to rebuild your whole system. You can actually just need to install a drive, and it can be even on the old motor. Of course, by reducing the electricity demand, you can also reduce the electricity bill. So actually the payback time can be as short as 6 months or 2 years.
Next, let's look at reuse. Reusing energy is about recovering excess heat from processes already running, heat that evaporates into thin air today.
Basically, excess heat is any heat that is rejected from a cooling system, a mechanical cooling system, or from an industrial process that is just rejecting heat. So excess heat is a significant opportunity because it is significantly unused today.
Excess heat is currently the world's largest untapped energy source, representing 2,860 terawatts per year in Europe alone. It's free heat released into the air everywhere from industrial processes, data centers, and even refrigerators in supermarkets. Using technology like bidirectional heat transfer, heat exchangers, heat recovery units, and heat pumps, we have put excess heat to use in our Danfoss factories in China, Poland, Denmark, and Finland.
For example, here at the Danfoss headquarters, we have this heat pump, which is cooling the data center that's also behind me, and then recovering the heat via the heat pump to the disk campus energy system.
Excess heat from metro stations, data centers, and more is lost every day on an industrial scale. But if captured and reused, this heat can be recirculated in district energy networks, replacing heating demand that is otherwise met by burning fossil fuels. In some cases, it can even be reused in the same unit that produced it. With excess heat, we can fuel industries, neighborhoods, and even cities with energy that would otherwise remain unused.
From our experience, every heat recovery or excess heat recovery project that we've worked on, in general, is going to have less than a 3-year payback.
Finally, let's look at resource. Once energy use is minimized and we've reused excess energy, we resource green energy by replacing fossil fuels with clean energy sources. Resourcing from fossil fuels to renewable electricity and green hydrogen can be achieved with power purchase agreements that secure green energy supply from renewable sources. This is exactly what we've done for our factory sites in China, the US, Denmark, and Germany. We have agreements in place that cover a 30% reduction towards our carbon neutrality in 2030. Of course, resourcing requires that factories first electrify wherever possible. Fortunately, up to 78% of industry's energy use can be electrified with technology already available today.
Heat pumps decarbonize by replacing fossil fuels with converted electrical energy input, typically by factor 2.5 into thermal output.
We're working together with companies like Cervix to develop industrial heat pumps. These solutions aim to deliver up to 130 degrees Celsius hot water and steam for energy-intense productions, where oil and gas used to be the only option.
We are collaborating with Danfoss on several ways. We do it with developing compressors on higher stage pressure, higher temperatures, but we also need different components, and that we are all doing together with Danfoss. At the moment, we are ready for making 130 degrees, and we're going to install it right here by the Gulpener Beer Brewery.
Just by optimizing the equipment that has to be driven by these industrial heat pumps, we have achieved 75% savings in energy per annum. And these are proven figures. This is not like a technologist making optimal calculation. This is really looking at energy bill and electrical company asking what's happening there.
So, for industries like food and beverage that have both cooling and heating processes, heat pumps are already available today. However, some sectors like chemicals, steel, and cement require higher temperatures, sometimes exceeding 800 degrees Celsius. Today, electrification seems out of reach, with many seeing fossil fuels as the only viable option. But solutions also exist to decarbonize these hard-to-electrify sectors.
There's a couple of things. First of all, chemical industry is very energy intensive. So we use a lot of energy, and that's why sort of transferring the energy source to a renewable source, of course, will help us a lot. The second one is that a lot of our processes intrinsically cause CO2 emissions. So for some cases, we have to look at different technologies to make our products. And the third one is that we have some applications where in order to get to high temperature, the only real solutions today is, let's say, burning fossil fuels to get to those high temperatures. And for those applications, we need to find new technologies to have the same chemical process reach the same temperature without the associated CO2 emissions. I would say this idea of reducing and reusing is kind of part of the DNA of the company. Any waste you produce is worth a lot. It is used as a heat source for the next plant. And I think this is what we try to now take to the next level. For instance, with heat pumps, taking the waste heat from one plant to a higher level steam to be used in another plant. And again, avoiding the use of fossil fuels to generate heat. The challenge is too big for one company to do by itself. So in general, we work a lot with partnerships. Very simply, we need to talk to regulators together. It's really an industry or several industries that need to make sure that the playing fields are level and that we get regulation that allows us to actually implement technologies.
Working together and using our resources smarter is crucial to decarbonize our most emissions-heavy sectors.
So to really ramp things up within the industry, it's really important that we do get that policy leadership. So it's great that we've had the recent COP announcements on doubling energy efficiency, tripling renewables, and aligning on those goals with industry is really key. Therefore, we need strong policy, strong regulation from governments, also incentives. So it's not just good for emissions reductions, it's good for the bottom line, and it has all these wider benefits to the business as well.
Now is the time to get to work, bridge the competence gaps ourselves, and inspire each other across industries to get the job done.
This can be done. It's possible to move towards net zero.
Make sure that if you have a motor, please have a drive.
This is not something you develop by sending each other emails.
Actions speak louder than words. Learn more about Decarbonization Explained and how we can partner together to decarbonize.